Alright, so unlike some video bloggers, I don't even want to call myself that, I have a lot of trouble doing working on this stuff with a camera like right between me and the work, so you're going to get the side angle and you're going to like it. So the board we need to get at is this guy here. Specifically, if I remember correctly, one. So it's going to be specifically these two transistors here, Q503 and Q109. From the schematic, I believe it's Q109. That's more likely the problem. Not 100% sure about that, but it looks like it from what I can understand from the schematic. But in any case, it doesn't matter. I'm going to try and replace both of them. It'll be easier that way. Well, anyway, we'll get the board out, and why don't we go do that now? And I'm just going to go ahead and undo all this stuff, and we'll be right back. Alright, so we're going to go ahead and start taking some of these boards out. I was originally going to take these cables out, but I think I'm going to leave them in up here, and I'm just going to go ahead and pull the controller board out right away, get that out of the way. I want to take pictures of where everything is underneath there, just so I don't forget. I shouldn't, but you know, I think these are so simple in terms of where everything's connected that as long as you have some idea of what you're doing, you don't wait a week between pulling it apart and putting it back together, and you should be good. But yeah, my memory's horrible, so how about I don't do that? All right. So I'm gonna go ahead. Pull. How's this come out? Yeah. Well, that's that capacitor's flapping in the wind. Oh, there we go. All right. That's out. That's annoying. Alright, so there is our controller board, and it's running God knows what. An SX6206 and a, geez, I don't know what the heck that is. There's a firmware ROM right there. Whoops, better if I actually put it on the camera. So there's the, I think the main processor. Well, maybe they're both there together, but one's NXP, one's Intel, so probably not. Agilent. Okay, yeah, so that's probably the HPI or GPIB. A couple of pissy little regulators there, all hanging out and doing all sorts of great stuff. What I don't see is I don't see a max 323 or 2232 for the serial port, so that's a little bizarre. Oh, wait a second, but you can tell on the back the traces go, oh, that's gross. Traces go from here all the way over to here somewhere, so if you look on the other side of the board here, maybe we will see something, but I just see a lot of jelly bean digital logic, so I don't know. Very odd. Well, maybe they're doing something integrated here on this side, so one of these is probably the GPIB, but maybe this other chip here is doing something for the RS-232. So we're going to go and put that here. Put that down for a moment. And we're going to continue with the disassembly. So now I'm going to go take another quick shot of this and continue pulling this apart. Alright, so I'm just going to go continue taking these out. Oopsies. So these are clearly power. Probably these are the main power connectors for the two channels. This is brilliant. Whoever did the layout here is a champ, because they put the tab. I don't know if you can see that. Here, hang on a second. We'll go and do a quick porta shot here. I don't know if you can see that, but the champ here said, oh yeah, we'll just whack some of these heat-sinked components here, and we'll put the tab to undo this on that side where it's like impossible to get at. Thanks. Way to go, Agilent. You're awesome. So, I'm just going to go fight with this for a second. Actually, as I mentioned before, I've taken apart a similar supply to do something, to do a similar repair. Actually, again, there's a pass transistor that was causing me grief. These two capacitors are flat. So this doesn't really surprise me. In fact, I kind of wonder whether or not the failure mode of these supplies is those damn transistors. So who knows? Okay, so that should be just about it. The last one is there's a grounding wire strapped here, which of course is probably impossible for you guys to see. There you go, a bit better. So there's a grounding wire strapped here that goes to the board down there, so I think that's all soldered in. So we're just going to go ahead and pull this out. Hopefully I remember to attach this, otherwise bad things will happen. TM. This is a cute trick too if you're pulling stuff apart, is if you're not sure you're going to remember where all of the bits and pieces are going to go. One really useful trick is to simply just go ahead and put the screws back in the in the sockets where you pulled them out from, and that will allow you to remember at least which screws go where. You still have to remember how the whole bit, all the bits and pieces go together, but at a minimum you don't have to actually remember which screws go where, if you're like me that have zero memory whatsoever. Okay, so I think I got all the wires. Of course, the trick will be putting them all back afterwards. So to do this properly, I'm just going to go and turn on the irons, because they're going to take a little while to warm up. So I don't have great, awesome irons like everybody else. Kill any wires. Alright, so this guy, again, it's fairly simple. 2 screws. Whole board just shifts right out. I'm going to go and pull back a little bit. Oh. Completely reframe shot. There you go. So there's a couple of screws right here. So you pull these out, the whole board shifts up like that and pops right off. So let's go ahead and do that. Pardon my fat arms in your way. Uh-oh, that feels like something is attached. What is attached? What is attached? Oh, the main power connector. The mains connector. Alright, there we go. Aha, we have a board. Now, aside from the ridiculous amount of dust, that's going to have to go get cleaned out. So those are our 2 transistors here. Anyway, so as you can see inside there, they're just tucked back there. So those are the 2. If you think those are a pain to get out, you're right. In fact, they're actually a real severe pain in the ass to get out. That is really annoying. Okay, I will have to go I'll go dust this off, and I will be right back. Alright, welcome back. So, I have chosen my method of attack, and basically what I've decided to do is this. So, this is channel 1 on this side right here. Of course, you can barely see that, so let's turn this way. Okay, so channel 1 is this right here, right? And our pass transistors are right down in here. Now, of course, because they have to be sucky like that, they are bolted into this big heatsink right here. So to make my life really hell, they put two big caps right here, so I can't get at them. So what I think I'm going to do, because I believe this is probably the easiest, I could try and desolder the whole heatsink, but that would mean a lot of pain, because I have to desolder all of the two bridges, the two bridge rectifiers that are here, and you know, the 4 pass transistors, and oh geez, no, screw that, too much pain. So what I'm going to do is I'm going to try and desolder these two caps and see if I can do that without killing them. I really hope I don't have to replace them, but anyway, we'll see. So let's go do that. And again, I just want to make sure I get the right side. So don't want to do all the work on the wrong channel and find out, oh nuts. So get our trusty handy dandy solder sucker over here, and we'll just do a quick probe and see how hard or easy this is going to be. This is probably all lead-free solder too, no less. That might not want to come out too easily. You might need maximum power. Unfortunately, I don't have a preheater or anything like that, so, or even well, I wouldn't want to hot air this, but I don't have a preheater, so I can't. Oh, hello, that's starting to melt nicely. Okay, well, all right, this might work. It's all coming out. It doesn't seem to be moving very much. So sometimes when doing this, applying a little bit of solder back to the joint helps. So we're going to give that a shot and see what happens. And this just helps with connectivity of the heat, conduction of the heat from the iron to the point of interest. Hopefully I don't make a hash of this pad either. That would be really bad. Now the really bad thing is I don't seem to be doing any damage whatsoever. I don't seem to be pulling this out. So now if you flex on the cap or whatever, you'll be able to see it. Okay, so I'm just going to go ahead and start getting rid of some of this solder and see what we can do. Okay. Wow, yeah, it's definitely on the ground. It's definitely on a ground plane-ish. Feels a little warm to the touch. I'm going to try and do this and I'll be back. Success! Haha! I have two huge caps. And these are each 12 millifarads, or 12,000 microfarads, so 63 volt. Nichicon Chemicon, 85 degrees C rated. Interesting. You would think that on a power supply you would have higher rated capacitors than that, but I guess not. Anyway, Apparently the guys at Agile know what they're doing, so we're not going to second guess them. Certainly I won't. So those came off. There's a little bit of nicking on the board, but meh, no big deal. What I'm going to do is I'm going to go ahead and I'm going to pull off, I'm going to desolder these two transistors right away, and then we'll go in there and unscrew them and get them off of there and get the replacements in. So let's go do that now. And I don't do any kind of fix-it work. I don't do this nearly enough to make it worthwhile to buy any kind of desoldering done, but that'd be really neat to have. But I don't, I do a lot of SMD stuff now, even as a hobbyist, so I don't really need to have, you know, those kinds of reworking tools. Although, it certainly would be neat. So I'm just going to bring out the big guns. Yeah, that's what I figured. And I mean, these solder suckers are nice too, because, you know, they cost practically nothing. They work fairly well. And as you can see, I mean, we're done basically. I'm just gonna go ahead and nudge these guys a little bit. So that they're free. There's a little bit of extra solder in it. We can probably get rid of that. Clean this up a little bit more. Apply some heat. If you're using this method of wiggling pins around, just make sure to heat up the pin before actually going to wiggle it around, because you can easily just go and wiggle the plated hole, through hole right off too, so be careful when you're doing that. This is definitely not the best rework method, but it'll be good enough for this. Also be careful because, you know, I mean, depending on your iron, this one has to be actually rather warm. So the issue is, of course, that as soon as you touch the PCB, you're starting to delaminate the thing, so be careful. What the hell? Alright. So we're just going to test that one's free, this one's not. Alright, so all three of those pins in each of those transistors are free. I'm going to just shut the, turn the irons down a bit. just do a quick brush off the board here, get rid of any additional crud that may have been thrown around. Alright, so now comes the fun part. Now we're going to go and, let's see if I can get that better. Now we're going to go and get those darned things out of there. Now this is something I was debating on exactly how to do this, and I think the best way is just to come in and clip those guys. So technically speaking, in hindsight, I didn't actually need to go and desolder those, but, or at least not the way I did. But I'm going to go, that just popped right out. Nice. So I'm just going to go ahead and clip these guys. And all those 3 leads just came right out, which is nice. Lost one. Maybe a bit less nice. Before we go and put those back in, we're also going to go ahead and clean those up with some isopropyl alcohol, because that's what you do. Right, so here, these 2 big caps here, I don't know if you can see them, but they're a little wiggly. I'm almost tempted to drop a dab of hot glue on there just to keep them from moving, but anyway, yeah, maybe they're fine. Who knows? Alright, so those... It's gonna come out. Oopsie. Alright. Don't want to lose the bajillion and a half insulating, isolating, and whatnot pads here. And indeed, those look like those are insulated. So that's a couple of washers with. You have to pardon me, I'm left-handed here, and I'm also off screen. But it's an insulated. Oops, there's a insulated washer right there. Goes, or insert that goes in on the inside, and there's a sill pad here too. Let's lever that off. Leave it. Yeah, there we go. And that is one fet. We'll go ahead and take the other one off. And then I'm going to go get the replacement. So I'm going to go do this, and we'll be right back. Alright, so everything is back together again. We're just going to go ahead and plug her in. But before we do that, we're going to do a quick pre-flight check, because when you're as forgetful as I am, it pays to look twice and screw up once. So we're going to do a quick check. I've done a quick check of all the cables inside here. Everything seems to be good. We've connected back our display here. We've got our 2 data control cables there, and I think that's everything. 2 power cables, main power, I should say, auxiliary power there, the 2 lower voltage cables here, fan, of course I screwed the heatsink in, bolted the analog board to the bottom, everything's good there, pardon me, hooked up our test wires, setup. So I think we are good to go. So I'm going to go plug that in, turn that on, and we'll either have working or at least one hell of a kaboom. Hey. Man, we don't even get an error. Huh. How uncool can that be? Alright, so we'll go set the limit here. By the way, I looked up the price of these rotary encoders because I'm thinking of replacing this one. They are $6.95 from Agilent, which sounds awesome until you realize or find out that they've got a minimum order amount, which sucks. So you have to order $50 worth of stuff from them. In this particular case, it might not be worthwhile ordering more than 1 encoder, maybe 2, but I mean, even then it's kind of silly. And I'm sure as heck not going to order $50 worth of encoders. So what I'm going to probably do is look around on their site and see if there's other parts I might need, like for example attenuators or things that it might be just generally adapters, stuff that might be generally useful that since I have to pay them an extra $40 anyway, I might as well get something that I'll use rather than not. So anyway, so 8 volts. Let's go ahead and crank that all the way back up to maximum there. 5 amps. Go make sure that we're nice and high there. And we'll turn the output on. So now we're getting 3.23 volts there. No problem. Turn the load on. And we're loaded at roughly just over 5 amps. Of course, this is output 1. And clearly, I haven't broken anything since we have voltage and current. And if I don't believe me, because quite frankly, I don't believe me sometimes, it can be a little ridiculous. Go ahead and turn that on like that. Get a slightly better angle there. Yeah, there we go. So go ahead and we'll measure the output like this. Alright, good, excellent. So it's 8.23. Now, of course, we're seeing a drop here of 0.2 volts, and that's because the 5 amps on these cables is, you're getting some voltage drop on that. So that's normal. No worries there. If I go here and just set some random voltage there, make sure I haven't broken this channel. 4.03, close enough for me. This, I think I seem to remember channel 2 needing probably a calibration, so anyway, we'll do that, but that's awesome. So the next step is for me to do the boring stuff and come back with a report in maybe about an hour whether or not this is holding up. So we'll see you in an hour. Alright, welcome back. Sorry for the hand holding. I'm just going to do a quick wrap up here. So we started at 8.24 volts, 5 amps, continuous. It's been about, give or take, about an hour now. And perfect. No fluctuations, no issues there. There's the other channel. It's not used. We still need calibration, but whatever. We're back in business. So it was just that. It was just this one little dicky MOSFET that was the problem. So everything's perfect. I didn't have to change the IRF 2807. That seems to be just fine. So glad I didn't muck around with that. And it still seems to be as good in terms of calibration, just fine. So that's perfect. It looks like yet another issue with a FET in one of these supplies. So thanks for watching again, and take care. Cheers.